Hey everyone, Kevin here from Focus Astronomy, and welcome back to another one of our Starstream virtual star parties. This takes place right here in Arizona. We stream it live to you, and it allows us to explore the night sky without ever leaving home, which is obviously a good thing right now because we can't do anything. Everything we're seeing tonight is being streamed live off of one of our telescopes. Tonight we are using our Skywatcher Esprit 120. That's about a 5-inch refractor. And we also have a piggyback telescope on top. It's a little 50 millimeter, so just over 2-inch little tiny telescope. And that's going to be used for our wide field targets tonight. So we have a bunch of stuff we're going to be checking out. This is actually one of the longer lists that I actually have. And I think we're almost at 14 objects for tonight's stream. So we're going to be busy tonight. Just to show what we're going to be looking at tonight, let me bring out our star chart here. Would help if it was in the middle. There we go. So like I said, we're going to be working on a lot of different targets tonight. We are officially in summer. So with that, there is a ton of amazing objects that are up this time of year. And especially if you can get out to dark skies, but there's so many other things that we can actually see even in town. And with the aid of our cameras tonight, we're going to be able to peer into some of the real gems of the summer sky. Now, the constellations tonight that we're going to be looking at, let me back out here real quick. This is what our night sky is going to be this evening. Obviously, it's not that dark, but this is actually what is up as far as constellations right now. Now, if you've been joining us in the past, you've done some of these virtual star parties. We started in the spring. We were working in Leo a lot. And as you can see, we're pretty much done with the constellation of Leo, and a lot of the spring and wintertime constellations are now gone. So Leo is setting in the west. All those galaxies that we were looking at only a couple months ago, those are now setting, and it's now giving rise to the summer constellations, which of course include Scorpio the Scorpion, Sagittarius, Aquila the Eagle, Cygnus the Swan, Lyra, Hercules, and very collection of others. And the nice thing about this time of year is that we have the Milky Way crossing the night sky. Now, unfortunately, we can't see that in light-polluted locations, but that doesn't mean we can't actually look in some of these constellations and catch some of those targets. The cameras that we have tonight are monochrome. They're black and white cameras, so they're very, very sensitive. Each telescope is loaded with a selection of filters, so we can actually switch through different things and isolate different wavelengths of light. So we're pretty excited to get to it tonight, and we're going to be checking out all kinds of phenomenal targets this evening. So we're going to get started. If you have any questions, feel free to write it over there in the chat. We're going to get the telescope on our first target. Just so everyone knows, our first target tonight is actually up in Cygnus the Swan. This is the Crescent Nebula, NGC 6888, which is actually right in the heart of Cygnus the Swan, not far from the bright star Sadir. So this will be our first target tonight. We're actually going to be starting in Cygnus this evening because there's a ton of nebulas. That's actually what, for the majority, most of the stuff we're going to be looking at tonight are nebulas because there are so many amazing targets up this evening. So let me switch this down and get our controls up and running. There we go. All right, so let me get the telescope over to the target. We were getting it all focused earlier, so we were good to go. There is a little bit of a breeze tonight, so if we're getting some streaking stars, that's what that's coming from. So bear with me on that. It's also really hot out this evening, so the cameras and the cooling systems on the cameras are really fighting to give us a good looking image tonight. So we'll do what we can with it. So first target, NGC 6888, the Crescent Nebula. This is a challenging nebula to see visually from. You really need a nice dark location. A telescope of around 10 inch, if you could get it to 12 or 14 or bigger, this nebula really comes out. So let me start the exposure. We are going to be moving into a narrowband filter this evening because a lot of these nebulas are emission nebulas. They emit their own light. So we're going to be using a hydrogen alpha filter a lot this evening. This is a filter that lets a very small amount of light in. Here's one right here. Looks like a little mirror. This is designed to let only a very small frequency of light through, and it cuts out all the light pollution and allows us to dig into the nighttime sky a lot more. So this will be really helpful. So popping up on the screen right now, this is NGC 6888, also known as the Crescent Nebula. I think it looks a lot like a brain. If you actually look up this nebula online, it has a ton of structure in it. It's a really unique object, and it's in the constellation of Cygnus the Swan. It's about 5,000 light years away, and about 25 light years in diameter. And it was originally discovered by William Herschel in 1792. Now, this is a really interesting nebula because it's actually from what's known as a Wolf-Rayet star, which is a star that's nearing the end of its life, and it's releasing this immense stellar wind that's coming off of the star. And this is actually energizing a lot of the material around there, giving off this really interesting structure. So let me stretch the image here, and you can start to see it a little bit more. It is a fairly faint object. There's a lot of actual hydrogen in the area right here. Let me see. Well, you guys are looking at that. There's a lot of, this whole region of the sky right here is basically full of nebulosity. Basically, the entire constellation of Cygnus is shrouded in nebulas, mostly composed of hydrogen gas. There is double ionized oxygen up there, but there's all kinds of stuff up here. I wanted to see if I could actually find an image that was just shot of this not too long ago, but I need to find it on the drives. But this is a really cool nebula to actually see. The main chunk of it right here, this outer portion, and then moving over here, this is what you would actually see in a telescope. If you want to try and view this, I recommend using like an ultra high contrast filter, like a UHC. And O3 would work too. There is some O3 in this object, but for the most part, a UHC filter would really be ideal for this target. So again, this is NGC 6888, the Crescent Nebula. If you ever have access to a large Dobsonian and a friend of yours is willing to share it, a telescope about 20 inches in aperture, this looks awesome. Especially from a dark sky location. And I was hoping to be able to show you guys a more colorized image of this. We shot it not that long ago and posted it on the Focus Astronomy pages. So let me see if I can pull that up really quick just to give you an idea. I wanted to show you all the nebulosity that's in this region, and it's really a spectacular image when you see all that's floating out there. Now, of course, our eyes are not sensitive enough to see a lot of the extended nebulosity. The nebula also has an outer shell composed of mostly oxygen, and it's a pretty cool region of the sky to photograph and all kinds of stuff. Here we go. Let me get this downloaded really quick. And we'll take a look at it just so you guys have something to actually see. Let's see. All right. So just so you guys can see, now this is a long exposure image, but if you were to sit on this target, I think this is like 6 hours of exposure time. This is through our 6-inch refractor, which is the bigger version of what we're using right now. But here is the colorized long exposure image of this target, just so you can see all the faint stuff that we can't get. We're only running 30-second exposures right now, and even with stacking the images on the fly, you really need to process and spend a lot of time photographing this region to get some of the faint details in there. But you can see how it looks a lot like a brain, and it's got this outer halo right there, which is an oxygen, composed of mainly oxygen, double ionized oxygen, using an O3 filter, and that's why it's blue. Nemo said, could you please share the software you're using for tracking, imaging, and processing? Yeah, this is SkyX Pro. This is what's from Software Bisque. We are running a Paramount MX tonight. That's kind of our main imaging mount. Since it holds so much weight and it's super accurate, that's what we're running tonight. And with that, we're running SkyX Pro, which controls all the software, all the hardware, the motor focuser, the 2 cameras we're running tonight, filter wheel, all the fun stuff essentially. So, but anyway, this is what the Crescent Nebula looks like, colorized, but you should be able to, you can kind of see all the structures in there that are sitting in there right now. So normally when you're going to be imaging a target like this, you're going to have the telescope taking long exposures, 5 minutes, 10 minutes for a single image, and then stacking all those images together to give you the detailed shot, which looks like this. And this was taken earlier this year when the object was quite low, and this is probably taken over the course of 6 nights when it was low, and I can only get about 2 hours a night. Now we could image it all night from the position, but this is multiple nights of imaging on that. So that is the Crescent Nebula, NGC 6888 in the constellation of Cygnus the Swan. Excuse me. So we're going to stop this, and we're actually going to make our way over to another region of Cygnus the Swan. This is actually one of my favorite nebulas, and we're going to see what we can get with this. All right. So our next target is actually the Veil Nebula. The Veil Nebula sits down in the northeastern wing of Cygnus the Swan. So here's Cygnus. We'll just make the Swan come up. Here's Cygnus the Swan right here. It starts with Albireo up here. You have Sadir in the middle and Deneb at the back of the Swan right there. So That is Cygnus the Swan. But down in the northeastern wing, off of this bright star, you'll notice there's another bright star. And this bright star, 52 Cygni, you can actually see naked eye from your backyard in a moderately light polluted location. I live in the middle of Phoenix. I can still see it. But in there is this massive supernova remnant complex called the Veil Nebula. This is a stunning region of the sky, and you really have to have a chance to see it. But we're going to try and get that tonight. And we're going to spend some time on this one because there's actually 3 major sections of this nebula. There's the Western Veil, the Eastern Veil, and then there's Pickering's Triangle and all the center nebulosity here in the middle. So what we're going to do is we're actually going to switch cameras to the top scope here. This is our little 50 millimeter refractor, just a tiny little telescope. It's only about 2 inches in diameter, but when you're equipped with the right equipment, you can still get some pretty amazing things even with small telescopes. When we're doing astrophotography, the advantage of it is the cameras are much more sensitive than the human eye will ever be. So it's not always about bigger and bigger and bigger. If you can't see it, you just take a longer exposure. Now, there is advantages to having larger telescopes, but that's not a huge deal for what we're doing tonight. So we're going to see what we can get with the tiny telescope and see what's visible in there. All right, so it's there. Let me get this centered really quick. So the telescope that's on top is not quite centered to the main telescope. And it's not the end of the world, because the field of view of that telescope on top, the little piggyback telescope, is so huge that it doesn't really matter. So we're going to try and center this up really quick so we can get a good view of it. So there we go. And then we'll move, once we do the whole target, then we'll move and do the sections of it all in the main scope, which is the 5-inch refractor, which it's piggybacked on. So we're going to try and get all of this in the field of view. This is a huge object. It actually spans 36 times the area of the full, or 3 times. Go back and look it up. It's much bigger than the full moon in the nighttime sky. So this is a huge object. This was originally discovered in 1787 by William Herschel. It's 2,000 light years away from the Earth, and I think we're close enough. So let's stop this and go back over our live stack, and we're gonna start taking some pictures of this region. So the telescope on top has a huge field of view. It's almost a telephoto lens, like on a camera. And we have another black and white camera up there and a special filter that is actually letting multiple wavelengths of light come through. It's made by a company called Optilong. It's called an L-enhance filter. And it lets hydrogen, double ionized oxygen, and H-beta through. And it works out generally really well when we're trying to shoot these nebulas because of the different objects or the different material that they actually emit. So we're going to start seeing some of that in here. And you can kind of start seeing it down here. This is 52 Cygni, the bright star. And this is the Western Veil that's coming out here. And you're going to see Pickering's Triangle. And I think our Eastern Veil is just outside of the field of view. I don't have quite a big enough sensor on this telescope to get the entire 3-degree field of view. You need a really big chip or very wide field of view to catch this whole object. So you have to break it up in sections. So that's what we're going to be doing tonight, is just trying to get a whole big chunk, and then we're going to go through with the larger telescope. We're going to spend probably a fair amount of time on this object as we go through the different regions, just so you can see it. But let me try to stretch some of this out. If you look close here, and the reason why this image looks so grainy, that's noise, electronic noise coming from the camera. And this happens in astrophotography as equipment heats up. It produces noise like static, and this is why you have to chill or cool the camera sensors in order to reduce that. Here in Arizona, where the summers are hot, even at night, even with the cooling on board, these cameras are fighting really hard right now to stay cool, so the images are going to be a little bit more grainy than we've seen in the past. In the wintertime, when it's cold outside, it's perfectly dark and no grain in there. So, and when you do astrophotography or stacking a bunch of images, it gets rid of all that. So this is the western veil right here. You can start to see Pickering's triangle, and we can't quite, it's just out of the field of view, grab the eastern veil. So we're going to stop this, and we're going to go to the main telescope, and it should pop it out really easily. So let me get it onto target, and let's get this rolling. Now the filter that's in the main telescope, unlike the one on the piggyback, is strictly letting hydrogen through. It is not letting any other wavelength of light pass. So this is really deep in the red part of the spectrum, very narrow piece of light, and this particular filter is very precise on that wavelength. So it's only going to let what the nebula is emitting through and cut everything else out. That allows us to get a really detailed look at that nebula. And of course our software is going to be a pain now. So let's get that connected real quick. Beauty of electronics is they don't always like to listen to you. Give me a second here. We'll get all hooked up again. And get the camera back on here. Just bear with me, guys. Little technical glitch. And then we'll get that back up here in a minute and start taking pictures once again. Okay, that's back on. We're going to leave that one off. That's good to go. We're going to move the filter we want in there. Okay, we should be good to go again. So let's get back on to our target. And there we go. So even when you're using some of the high-end equipment that we're using tonight, it can still glitch. It's just part of how things work. That's the reality of it. So now we're back on the target we want to be on. Let's get this going. Okay. Nemo said, on the fly, I like to use Deep Sky Stacker because it's really simplistic. I do have PixInsight. I do a lot of post-processing in PixInsight and the stacking in Deep Sky Stacker at the moment. I know PixInsight does everything else, but for the most part, yeah, I stack in Deep Sky Stacker, do all my major processing and adjustments in PixInsight, and then do any final adjustments in Photoshop. That's generally how we do that. So, all right, so we're on the Veil Nebula right now, and this is 52 Cygni, that bright star that you could see with your naked eye right in the center. And you can start to see the nebula come through here. Let's try to stretch it a little bit. You can see it coming through really well. As we get more exposure time, it'll look a little bit better. If we were to leave this on there, this nebula is really stunning. And the reason why this one's really quite cool is because it's so intricate. And the amount of detail that sits inside of here is really, really impressive. And I really like it because it just like ribbons of fine detail. I'm going to bring up another processed image just to show you. Just because tonight we're dealing with a lot of heat and stuff, it's hard to get some of this. So I'll bring up a processed image just because there's a lot of little faint tendrils in there that we're not going to get to see. So I know you guys like seeing the other one. This is a black and white image. It was not colorized. This is actually using the exact same camera setup that we're running right now. So this is what we're actually sitting on right now. This is the Western Veil, NGC 6960. This is 52 Cygni right in the middle, but this is the object you can actually see. There is right there, and then 52 Cygni. This is all that's in there, so you can see all those little really delicate filaments that come off of this. And this was a supernova. This was a star that was much larger than our sun that died and then detonated really violently, sending a ray of dust and gas out into space. So this is the Western Veil Nebula, NGC 6960. This was probably about 15,000 years ago, and the star was about 20 times more massive than our sun. And that's what produced the Veil Nebula. And of course, this is in the constellation of Cygnus, the Swan, about 2,000 light years away, and spans about 100 light years in diameter. So it's huge. Most telescopes aren't going to be able to see the entire field. You actually have to take it in pieces. So let me actually stop here. And we're going to go up to the other side of the veil, which is known as the Eastern Veil. And the Eastern Veil is actually broken up into two categorized targets. I don't know why, but that's just how it was categorized. But we'll point it out real quick. So this is the Eastern Veil Nebula at this point. This is NGC 6992 and 6995. And the Eastern Veil is actually brighter. It's a little easier to see. It has, in its own right, its own details. Some really stunning details are in there. So it's a very cool object to see. One of my favorites to show people just because it's so detailed, and the story behind it's really kind of cool too. It's a supernova remnant star that died violently. So here's the first part of the Eastern Veil. This is NGC 6992, and then over on the edge over here you have NGC 6995, where it kind of comes down on its own. And as you can see, this one's actually a fair bit brighter. There's a lot of detail in this that you can see. With large telescopes, you can actually see a lot of these really delicate filaments and spend hours just weaving your way through there. So if you ever get a chance to be at a dark location far from city lights and you have access to a large telescope, have that owner or operator throw that scope on this object and check it out. So this is the Veil Nebula. Again, we did the Western Veil, NGC 6960. Now we're on the Eastern Veil, NGC 6992 and NGC 6995. And this is in the constellation of Cygnus. Let me get a drink here. There we go. Lots of talking. All right. So the telescope that was running on top is kind of giving me a fit right now. So we're going to kind of avoid using that. I think that was probably one of the reasons it was having a little bit of a fit earlier. So this next target, we're actually not going to be able to get the entire thing in the field of view. Much like the Veil Nebula, this is a huge object. It's a massive, what they call H2 region, or hydrogen region. It's just off the bright star Deneb, just to show you where this is at. So we're done with the Veil. Here was the Western Veil. Here's the Eastern Veil. There goes a satellite. So we've actually moved on to NGC 7000, the North American Nebula, and we won't be able to get the whole field of view, but you can actually see how it looks like the North American Nebula. You've got what would be Mexico. Here's the Gulf. Florida would be kind of over here, and then you have the West Coast down over here, and then the Pelican Nebula is this region over here. So there's two portions. So we're going to be focusing on the main North American Nebula. We're going to try to get right along this region right here called the Great Wall, or the Cygnus Wall is what it's known as. There's a lot of structure down in here, mostly hydrogen. This is a big emission nebula, so this nebula is emitting its own light. The stars that are in there are exciting the gas that's in that nebula and causing it to glow, kind of like a neon sign. So it's actually pretty neat thing to see. So we're going to start up the camera here and try to get that. Now, the North American Nebula, or NGC 7000, it spans about 135 light years in diameter. And if you're new here and you're not aware, I should have broken this down earlier. I've done it in the past. Light year is kind of the measuring stick for astronomy. Miles is just too small. That's like trying to measure a mile in millimeters. It just is ridiculous. So for astronomy, we are actually using light years, and a light year is 6 trillion miles. So when I say something is 135 light years in diameter, you would take 135 and times that by 6 trillion, and there's your distance in miles. So it's big. So we're on the North American Nebula right now. This is 1,600 light years away. It was originally discovered by William Herschel in 1786. This is a huge hydrogen region in the constellation of Cygnus the Swan, not far from the bright star Deneb, which is the tail star of Cygnus. Its next door neighbor nebula, which is IC 5070, that's the Pelican Nebula. That was that little neighboring nebula I showed a minute ago. There we go. So all this gray right here, and like I said, the field of view is just too big. We can't fit it all in this field of view. Let me stop this. We're going to try to move it over a little bit and see if we can kind of center up the nebula a little bit more. Because we want to actually be down here. We want to be in the Gulf of Mexico area. So we're going to slew the telescope down there. And then we'll get back on the camera here. That's better. The Mexico region of this nebula, known as the Cygnus Wall, is just a really dense cloud of hydrogen. There's some oxygen and some sulfur in there too, and a lot of other trace elements, but it's mostly hydrogen. That's why when you see pictures of this nebula, it's red. This hydrogen generally glows red. I have another picture of that target somewhere in here. So while that's working on it, this is a more recent one too. Right here, is actually the Cygnus wall. Let me try to stretch this a little bit. You can actually see it right down in here. So pretty neat. Here's that picture. I'm going to pull up another colorized picture just so you guys can see. This was actually taken with a tiny little 2-inch telescope. 2-inch telescope that's riding on back of the main telescope, the one that was giving us our wide field. So this is going to pop up here. This is what we're looking at. This is the North American Nebula, and the telescope we're running on is right down here. But you can actually see there's the West Coast, there's Mexico, there's the Gulf, there's where will be Florida. Excuse me. And then work up the East Coast there. So, and then this is the Pelican Nebula right over here, IC 5070, but we're focusing on that. So, lots and lots of dust floating up in there right now. So you can actually see, let me flip our image here. Here's how it's oriented. So here's the Cygnus wall. Cygnus wall's right here. You can see how it's more structured. This is right here is what we're looking at. So this is actually hydrogen alpha. So we've, like I said earlier, it's a very narrow wavelength of light. For my imagers that are in the audience, if you want to know, this is a chroma 3 nanometer hydrogen alpha filter. So it's super precise on that wavelength of light. It gives us a lot of structure to the nebula itself. So if we were to leave this on there, we'd get a lot of amazing detail. So maybe we'll image this later tonight and we'll post something in the morning about it. But so this is a star forming region. All this hydrogen, which most emission nebulas are, is condensing down and making new stars. And these are more known as H2 regions. And lots of galaxies, even outside of our own, have these regions. You might see some images of galaxies that have little red puffs out in the outer arms, and those are called H2 regions. And that's basically glowing hydrogen that's forming new stars and new solar systems and so on and so forth. Most of the objects that we're seeing tonight are doing the same thing. And that's what's happening here in NGC 7000. It's actually condensing down and making new stars with all that hydrogen. Now it will take billions of years for those stars to become their own thing. But that's what's going on in this region right here. So again, this is NGC 7000. If you want to observe this, you need to be in a fairly dark sky location with a telescope with a really wide field of view. The interesting thing about this nebula is you don't need a lot of aperture to see it. You can see it in like a 3-inch telescope. This is one of those objects that requires a large field of view and a good contrasty night so you can pull it out of the background. And this is something that you can do even in a pair of binoculars as long as you know what you're looking for. It's a very impressive object to observe. So if you ever find yourself out at a star party, give it a try. NGC 7000. It's pretty impressive. Jeff Lucas, astrophotographer. I have a question. Is it good to use f2 narrowband filters for refractors and Newtonians? You can use them. They're perfectly fine. I've never used the f2 filters, and Botter, who makes these filters, they're a really reputable company. They make awesome filters, but it's really hard to find the bandpass of those filters. And for those of you who don't know, when you're I don't know where I went. Where did I put my filter? When you are getting a narrowband filter like this, they make them in different what are known as band passes. Basically, how on how on band, or so wavelengths of light, they talk about it in a band of light. So the more precise the filter, or the smaller the band pass, the more detail you can see in a nebula in your image. So this one right here, this is from Astronomics. It's a 6 nanometer filter. Pretty friendly budget filter. Works really well. 7 nanometer or less is generally good if you're imaging in town, because you can get through the city lights and it cuts a lot of the moonlight out. You can image with a full moon with this filter with no problem. The filter that you see right now working on the image, this is a 3 nanometer, so it's very, very precise. Our whole filter wheel that houses the filters we're using tonight, all 3 of our narrowband filters, our hydrogen filter, our oxygen 3 filter, and our sulfur 2, all of those are 3 nanometers because we use them for educational purposes and really heavily light polluted locations, so it gets rid of the light pollution. So Jeff, to kind of come back around, the Botter filters, the F2s, are really broad because when you're using a fast system, if you're using a filter that's too narrow, it'll clip the wavelength of light and it won't work well on a fast system. That being said, you can go narrower than even the F2 filters, and like George was saying there in the comments, they're probably somewhere around 12 or 10 nanometers, which is fine. Nothing wrong with it, but you can go narrower. It depends on how fast your telescope is, though. So look at the F ratio on your telescope. You can go, even if you're using like a hyperstar, we like ours right here, like our Starizona hyperstar we use for our C14. This is an f1.9 system when it's on our C14. We use a 7 nanometer Optolong H alpha filter on that, and it works just fine. So even if you're using fast systems, you can go narrower. I'd probably say about 7 nanometers ish is where you could get to, and there's a difference between 7 and 10 nanometer. It's just going to give you more contrast. So that's probably a lot more than you were bargaining for, but hopefully that answered your question. But if you're on a budget, the Astronomic filters are really nice. They're made in Germany. Phenomenal filters. And then the Optolong filters are very nice too. So kind of pick your poison at that point. So all kinds of stuff. All right, so this was the North American Nebula, NGC 7000. This is the Great Cygnus Wall, which is a big hydrogen structure, and the lower portion and the Mexico portion of the nebula. So something cool. So we're going to stop this right now, and we're actually going to flip over to our next target. Our next target is a real gem of the nighttime sky. This thing is easy to see in light polluted locations. It's a beautiful object to see in dark skies. You can see it in binoculars and small telescopes. You don't need a lot of aperture. And it's an excellent, and this is a great nebula to see right now, especially if you're just getting started in astronomy. This is M8, the Lagoon Nebula. This is gonna just pop in this telescope. It has a lot of hydrogen. It is a star forming region again. This is about 6,000 light years away, and we've now moved from Cygnus, the swan, down to the southern sky. This is in the constellation of Sagittarius, and this is an awesome nebula, originally discovered by Italian astronomer Giovanni Ordurana. I probably butchered that, sorry. but it was actually not brought into the Messier catalog, because when you actually hear, oh, M8, that refers to Charles Messier. He was a comet hunter French astronomer and comet hunter in the 1700s. And he would categorize different things that he thought might be a comet, didn't turn out to be. So he would document this. The Messier catalog now for astronomers is kind of the most basic deep sky observing list of objects. They're all relatively easy to see, and when you get started in astronomy, the Messier list is generally what you start with. That being said, what you're seeing right now is M8. This is the 8th addition to the Messier catalog, also known as the Lagoon Nebula. This is a really elaborate nebula. It's got a lot of pinks in it. There's a lot of crazy structure inside of here. It's a star-forming region, so the dust is condensing down, making new stars. And within it, you can see there's actually a small collection of stars in the center. That's an open cluster of stars known as NGC 6530. But this is the Lagoon Nebula. This is actually located in the constellation of Sagittarius. Was originally found in 1654 by Italian astronomers, but was not documented as a Messier target until 1764. So this is the Lagoon. This is using the hydrogen alpha filter. This nebula has a ton of hydrogen inside of it, so there's a lot of detail in here. Now, what we're gonna do real quick, actually no, we'll do this trick later. We've got a couple objects to go, and we'll do the light. There's an experiment that we can do to show what different filters can do for us and why we use different filters for studying the nighttime sky. So there's an object that we have coming up on the list that reacts really good to these filters on all the wavelengths, so we'll go to that in a minute. But this is the Lagoon Nebula. If you're just getting started in astronomy this time of year, this is definitely a target you should be going out and viewing. It's not going to look like this. The cameras are much more sensitive, but you'll still be able to see the glow. It's cool to see, even if it's just a little bit, it's still cool to see some of the detail. Let me try to stretch this real quick just to see what's in there. But you can see just all this intricate detail. But if you ever want to actually see this nebula, if you can get out away from the city lights with a 5 or 6 inch telescope, obviously if you have a bigger telescope, that's great. You'll see more of the nebula, and you can actually use filters to visually see stuff too, like a UHC, ultra high contrast, or an O3 filter for visual. That can help bring out some of this cool nebula stuff and the details. And of course, if you're into astrophotography, then the cameras and the filters, as you can see right here, really make up for that and highlighting a lot of stuff. So this is the Lagoon Nebula M8 in the constellation of Sagittarius. All right, so we're gonna flip over to the next door neighbor of the Lagoon Nebula, and it's not far. This one's really cool. They're all really cool, obviously, but this is right next door. If you have a big enough telescope, you could actually get both of them in the same field of view. And this one we're going to have to mess with different filters on, because the narrowband filter, like the hydrogen, is really helpful for certain aspects of this nebula, but not all aspects of it. So we're going to wait for the image to come up here. So we're still in Sagittarius. This is M20, the Trifid Nebula. This is one of my favorites because it's got a lot going on for it. You get a little taste of everything in this nebula. So we're going to get that up there. So there's the Trifid. That's not the whole thing, though. There's another section of this nebula that this particular filter blocks. And we'll switch filters here in a second. We'll go to a more visual filter and see if we can bring out that extent of the rest of the nebula. But while we're on this portion of it, the Lagoon Nebula, the Trifid Nebula, M20, actually contains several different types of objects. So what we're seeing right here is the Emission Nebula. So if this was in color, this would be reddish pink. And then you'll notice that portion of the nebula is broken up into three major sections by this dark nebula running through the middle. So there's two types right there. You have Emission Nebula, and then you have a dark nebula, which is breaking that up. Now, there's also more going on here, but in order for us to see it, we're going to have to flip filters here. We're going to lose a little bit of the detail, but we need to be able to see everything that's going on. So there's going to be a lot more stars that come up here. And because we're not running that narrowband filter, we're letting all the light through now. This is our luminance filter, which is basically letting all wavelengths of light through. But what this is going to do is hopefully allow us to see all the major portions of the Trifid Nebula, or M20. While we're waiting for that, this was discovered by Charles Messier. This is why it has the M for Messier. This is the 20th entry, discovered in 1764. It's about 4,100 light years away from the Earth and about 40 light years in diameter. So as you can see, there's a lot more going on in there, and lots of light pollution out there. This filter does not block any of that. So what you're seeing here, and we're going to have to fight with this a little bit to try and let me see if I can flip a filter in here just to make this a little more tolerable. This is a luminance filter. A luminance filter is something that we use in astronomy to basically collect the major structure of an image when you're doing color images. Bad part about this is it lets all the light through, including light pollution. Now we can get around that by using light pollution filters, but we don't have that in this wheel. So we're going to actually flip our green filter, which will only let green light through. And it should help with the contrast a little bit more to get rid of some of this light. There we go. Problem is it's going to knock out some of that stuff. So if you guys look closely, it's far from being the best image. We can still get the Emission Nebula side right over here. There's the dark nebulas running through there. And then over here, you'll actually notice that there's another nebula in there. It's all part of the Trifid Nebula, but this glow you see over here is a reflection nebula. That's basically dust that's reflecting starlight, and it's blue. It's this really almost baby blue. It's very, very pretty. So that's in this region of the nebula. And then over here we have the dark nebula that's breaking up above the Emission Nebula. So you're getting all three major types of nebulas in one object. So it's a really unique object. It can be a little bit more difficult to make out some of the structures visually. You should be able to see a lot of the glow in a small telescope, especially from a dark sky location. But you really want to make sure you're in a good spot to get a lot of the major detail. To really get the detail out of the dark lanes there, you want a really good sized telescope, 16-inch or bigger. It really does make some of the detail really pop out more. So we're going to move the hydrogen filter back into place here, just to pop that back so we're ready for the next set of objects. But again, this is the Trifid Nebula M20, constellation of Sagittarius, 4,100 light years away, 40 light years in diameter. A good example of all three major types of nebula: emission, dark, and reflection. So you get kind of the trio, if you will, in there. So something cool to see. We're gonna get the hydrogen filter back into place, and this really shows you the power of these filters. We're going from visible light, switching right over to hydrogen. You can see how it just closes out all that extra glow and crap basically in the sky, and really pops the contrast out on this target without much effort at all. So good filters really help with that. So we're going to stop here. We're going to move to our next target. Our next target is one that is really quite famous. It's probably one of the most famous nebulas in the sky. And we're on it. All right. So the nebula that we're on right now is one of the most famous nebulas to be shot by the Hubble Space Telescope. This is the Eagle Nebula, or M16. Everyone has probably seen the picture of this. It's called Pillars of Creation, and it's a really famous image from the Hubble Space Telescope that shows the details in these dust pillars that are within this nebula. Now, unfortunately, visually, you can't really see it too well. It looks more like a star cluster with a subtle glow visually, even in a large telescope. It's not until you bring the cameras in with the filters that really start to bring out more of that detail. So this is that nebula in hydrogen alpha. It does have some stars in the middle there that are causing that nebula to glow. But what you can actually see here is you can see where it gets its name. Right in the middle here, you see these pillars or spires of dust. And these are just these regions right over here. Kind of zoom in on this real quick. These regions, these pillars that actually make up the head of the eagle, or the beak of the eagle and the nebula, those are 4 to 5 light years long. So these are huge structures. And pictures from the Hubble Space Telescope actually show us that this is an active star-forming region where that dust is condensing down, making new stars and hopefully new solar systems in the future. So pretty cool stuff happening in here. This is about 6,000 light years away. It's in the constellation of Serpens. It's about 50 light years in diameter, and I can actually show you where we're at. We're right up here, M16. So this is just right up here, just above Sagittarius. And that is the Eagle Nebula. Now, one thing I wanted to show you guys on this is, like I said earlier, this telescope is equipped with different filters. We have a luminance filter, which we talked about earlier on the Trifid. It lets all the light through. We have a red, green, and blue, and those do exactly what you think they do. They let red light, green light, blue light through, and that's how you build a color image with a black and white camera. You take some images through the red, through the green, through the blue, you put them all together, and you get your final image. Now, we also have what are called narrowband filters, like the hydrogen filter that we talked about. And these are designed to let very specific wavelengths of light through, so we can actually do chemistry with astronomy. So this is hydrogen. This is light that's ionized. This is actually hydrogen. So this is way over in the red part of the spectrum. Now we're going to stop this and we're going to actually flip it over to the oxygen 3, which is going to show us double ionized oxygen in this object. And what I want you to take a look at is the dramatic change in what is visible in hydrogen to oxygen. And this is why we use these filters, because we're actually able to get different structures within an object by isolating different wavelengths of light. The telescope that we're using tonight's an Esprit 120. It has a prototype reducer on the back of it. It's not the Star Arizona reducer. The Apex is not out tonight, so this is a Esprit 120. The 150 is actually up on the rack in the garage. So we're using the 120 refractor right now. A little wider field of view, and has a prototype reducer on the back of it. So we're running f5.4 right now for all the astronomers out there. So this is the Eagle Nebula in oxygen. You can see there's not as much detail in there. So, and the chips aren't very sensitive, or the cameras aren't very sensitive to this type of wavelength of light. So we use different filters to isolate different wavelengths in order to study different portions of the spectrum. And with that, we can see all different kinds of details on these nebulas. Now, M16, what we're seeing right here, this was discovered by a French astronomer in 1745. It is another star-forming region. This is composed of mostly hydrogen, but there's also other trace elements of oxygen, sulfur, and some other cool stuff in there as well. And this is about 58 light years in diameter, so it's a pretty good sized nebula as well. Now, visually, like I said earlier, if you go to a dark location, it's going to look like a star cluster with some haze around it. You're going to need a fairly big telescope and good seeing conditions in order to start to resolve the eagle head itself, or the pillars. And when I mean large, we're talking 14, 15 or bigger, to really start getting the structure in there. So this is a bit of a challenging target when you're talking about the detail that we want to see in there. The cameras are really take it home, and because they're just so much more sensitive than our eye will ever be. All right, so the next target we're going to flip to is, again, right next door to this one. That was M16. We're now moving to M17, which is known as the Swan or the Omega Nebula. This is another star-forming region. This one's really pretty because it looks like a swan floating across a lake. It has a lot of great extension of nebulosity moving out into space. And this is about 6,000 light years away. It's in the constellation of Sagittarius, just inside the Sagittarius border. And it's 15 light years in diameter, so it's not the biggest nebula out there, but it's a pretty considerable space, wouldn't you think? All right, so this is the Swan Nebula. The Swan's pretty cool because it actually looks, here's the head, and then here's the body. It looks like a swan floating on a lake. Visually in a telescope, you're not going to see these outer extensions of nebulosity. You're just going to see the center portion right here, and that's where it gets the name, the Swan Nebula. Now, it's also called the Lobster Nebula or the Omega Nebula. I haven't quite gotten all that, but whatever you want to call it. But yeah, this is the Swan Nebula, or M17, in the constellation of Sagittarius. 6,000 light years away, 15 light years in diameter. This is a fun one to do because it actually looks like what you're describing. It looks like a swan. Very good with either an O3 filter or a UHC filter is what I would use for these visually. Those can also be helpful for in-town viewing. But that is the Swan Nebula, M17. Another emission nebula, so the stars in the nebula are causing the dust to glow and give off its light. So very, very cool object in the Milky Way. Not far from M16. So you're getting close to almost 2 for 1 with this particular setup. But that is the Swan Nebula, M17, constellation of Sagittarius. We didn't spend a whole lot of time on this target. If you have any questions, you can always either email or contact us on social media. But we've got a couple more targets to go, and we're running out of time. So we're going to move on to our next object of choice. Okay. So this particular target that we're going to be working with is not even so much about what is there, it's more the fact of what isn't there. So this is something pretty cool. And this is called B as in boy, 72, also known as the Snake Nebula. So this is going to hopefully come out. It's in a very dense star field. This is a dark nebula, and a dark nebula is basically a dense cloud of dust and gas and other molecular particles that are clumped together, and they're so tight that it's causing light to be blocked by the background star field. And this is in a very rich area for stars. We are in the Milky Way arms, not far from the core of the galaxy. So it's going to be hard to see. Let's see. It's right here. We might have to wait for the exposures to pick up again. But dark nebulas are a very, very neat, off the beaten path set of objects. For the most part, most of them were discovered or cataloged by E. Barnard, and he was an astronomer and really a pioneer of astrophotography in the early 1900s, late 1800s. He actually used glass plates. So you actually put the plate in the telescope, open the shutter, and you'd actually have to sit there for as long as the exposure is going to be. And these glass plates are not that sensitive, so you'd have to sit there most of the night, freezing your butt off, controlling the telescope and making sure you're getting on target the way you want to. Nowadays we have digital electronics that help us with a lot of that, so you can kind of make your way around it. But having stuff like this makes it a lot easier. I don't know if you can see it. You can kind of see there's some clumps in here. And these clumps are basically the dark nebula. So you notice there's a ton of stars and then it just stops. You can find dark nebula sprinkled all throughout the galaxy, but they mostly are in heavily star filled locations. And it's just molecular dust that's blocking the obstruction of the background stars. And this is 650 light years away in the constellation of Ophiuchus. Now, if you're ever interested in learning about the E. Barnard Dark Nebula catalog, or the Barnard catalog, there is actually a book out there, and it's actually a remake. Let me see if I can find it real quick for you. So it's called a photographic atlas of selected regions of the Milky Way. And it goes over all the locations that Barnard himself selected. Now like I said, there is a new version out. They're available on Amazon. It is a fairly expensive book, but it's a lot cheaper than the original books. The original books, if you can find them, go for $5,000 or $6,000 or $7,000 for them. And what was interesting is that E.E. Barnard himself selected all the prints to go into the older books. So he physically worked with all 700 copies of that book, selecting the individual pictures. The unfortunate part is these books are very, very hard to find. There's not many of them out there anymore. And if they are out there, you really need to basically know someone who's got it, or the observatory has to be willing to bring it out. Because of their expense, they're generally locked up in the safes, which is for good reason. They are old books and they need to be protected, especially ones that carry such historical value as the Selected Regions of the Milky Way book. Now, like I said, you can pick one up at online, and it gives you everything that you want to see. All right, we're going to stop this real quick. And we're going to go over to another target. So we're pretty much finished with a lot of our nebulas tonight. We've got a couple targets left over. These are mostly star clusters. So the first one here is M24, also known as the Sagittarius star cloud. And M24 was originally discovered by Charles Messier in 1764. There is word of possibly that being documented earlier, much earlier, but that would be before most of the major technologies. The Sagittarius star cloud obviously is in the constellation of Sagittarius at about 6,000 light years. I'm sorry, 600 light years. This is not far from the Milky Way core, and it's just dense. So all the little dots that you see in here are all stars, and it's the whole cloud itself. The cluster in the middle is just part of that cloud, so you can ignore it at this point. But the Sagittarius star cloud counts over 1,000 stars and is roughly 16,000 light years in volume. So if you could cap all this, you can actually get away with a lot of stuff. HNAU. Yeah, this is from Phoenix. Now, with astrophotography and the right equipment, you can get away with a lot of stuff, even in light-polluted locations. And that's kind of the whole point of our webcast here, is that you can do so much astronomy from home. You know, it would be great if we were all doing what we normally do with our hands-on outreach programs and schools and star parties. You know, we would all rather life be normal, but unfortunately it's not. So the live imaging that we're doing right now allows us to continue the outreach, but also show what's capable from home. All the equipment that we're using tonight is just off-the-shelf equipment. You don't even need stuff this nice to get images that are good too. So it's just something to think about. But this is the Sagittarius star cloud, M24, 600 light years away. You really need a wide field of view. The telescope that we're using tonight doesn't even do it justice at this point. We're literally looking through the middle of it, but every single little white point is a star with over 1,000 points in certain areas. And on the sides of this star cloud, it's actually framed up by two dark nebulas, which is B92 and B93. And it's also suspected that this nebula is about 220 million years old. So, vintage. This is an amazing object to look at when you're in a dark location. Binoculars do a phenomenal job. You don't need anything big or elaborate. You just need something with a big old field of view. So this is a really cool one to see. It is naked eye visible from dark sky locations. So there is a lot that you can actually see out there. Just go give it a try. Go in your backyard and explore. There's a lot of people that'll be like, oh, this is a waste of time. It's not a dark sky location, blah, blah, blah. That may be true, but there's a lot of good things that you can do from your backyard and see as well. So, don't take that for a total face value when someone says, oh, you can't do this from home. Yes, you can. Dark skies would be better, but, you have to work with the cards that you're dealt. So anyway, this is M24, the Sagittarius star cloud. All right, we're going to wrap this up. We've got 2 objects left. All right, so this next one is called M6 or Messier 6. This is the butterfly cluster. It's in the constellation of Scorpius. The Scorpion at about 15,000 light years away, about 12 light years in diameter. So, very cool little region of the sky. This looks a lot like a butterfly. It's an open cluster of stars. That's why M6 is known as the butterfly cluster. Constellation of Scorpius, 980 light years from Earth, 12 light years in diameter, and first recorded in 1654 by Italian astronomers, but it wasn't documented with Charles Messier as M6 until 1764. So there it is. There's the butterfly. You can kind of see it. So here's one wing. Here would be the body, and here's the other wing. So it looks like a butterfly. This looks great in binoculars and a small telescope. You do not need anything elaborate to actually look at this. You can see it from city lights. It's fun to share with people. And if you ever get a dark sky location, even more stars become visible. But right now they're saying about 120 stars are visible in this cluster, which isn't bad for being 24,000 light years from the galactic center. And what's cool about this particular cluster is it's 204 million years to orbit the core of the galaxy of our Milky Way. So this is M6, the butterfly. It is an open cluster in the constellation of Scorpius, the Scorpion. A great cluster if you're just getting started, especially if you don't have a telescope, small pair of binoculars, or a small telescope work just fine. So very, very neat to give a shot. So that is M6, the butterfly cluster. All right. This is our last object on the list tonight, so thank you all for joining me this evening, because we are getting up to about half an hour or hour and a half mark, which is normally when we cut it. If you ever have any questions or targets I didn't get to, you can always email me at focusastronomy@gmail.com or visit the website. The webcasts are these virtual star parties. We've been doing it every other week. Right now, we're going to reduce that down to maybe one a month. That way it gives us time for the night sky to move and gives us different targets to see. On top of that, it's hard running these things. There's a lot that has to go in, like the observing notes and picking the targets. There's a lot that goes into these virtual star parties. So we're going to continue them, but we're looking at offering them once a month at this point. We're not going to do every other week just because it's too tedious. And then here in Arizona, we're about to get to monsoon season. So with that being said, there's just not a lot of reliable weather that's going to be coming up. So that's something to keep in mind. All right, so we're on the last target of the night. This is the Ptolemy's cluster, or M7, constellation of Scorpio, the Scorpion, 980 light years away and about 12 light years in diameter. This was first recorded in 130 AD by Greek astronomer Ptolemy. There's also he was also a mathematician, but he helped us understand a lot of what's going on up there. And of course, he has a cluster named after him, and there's a crater on the moon named after him as well. So that is the Ptolemy cluster. And here's a picture of Ptolemy's cluster right in there. Kind of looks like the butterfly, but a little bit different. Now, Charles Messier added this to his collection in 1764. And noted that it was 2 million years old. I'm sorry, the cluster itself is 200 million years old. So, vintage. All right. Well, that brings us up to about our hour-and-a-half mark, which is generally where we round out these star parties. I thank you all for joining me this evening. I would like to take a minute, though, really quick. If you have not had a chance to get out and observe Comet Neowise in the morning, we are getting to that transition period right now where the comet is moving from the evening sky, or the morning sky, to the evening sky. It has been visible. Let me bring up that comet shot real quick. This is Comet Neowise, C2020 F3 Neowise, and this is up in the early morning hours, somewhere between 4:30 a.m. It's getting really low as of this morning, so if you get up tomorrow morning, it is going to get low in the northeast horizon, and then hopefully come back up around the 15th or 16th, which will have it in the evening sky. But this is a naked eye visible comet. You don't need any type of optic, just your eyes and a little bit of interest. Go out and look for it while you can. It's very rare, especially in the northern hemisphere, where we ever have a chance to have a naked eye comet. So this is worth taking a look at. And it's going to become visible in the evening starting the 15th or 16th of this month. We're just going to have to see what happens with it, because it is moving away from the sun, but it's also getting closer to us for a close flyby pass on the 22nd or 23rd. So this is definitely worth taking a look at while you can, because it's such a rare sight. So again, this is Comet C2020 F3 Neowise. It's all over the news on where you can see it, but it's definitely worth getting up and checking that out. But all right, everyone. Thank you so much for joining me this evening. Keep an eye out. We might be doing a special webcast in the next couple weeks if Comet Neowise gets interesting over the next couple weeks and becomes easily visible. We also have some of the planets starting to show up in the nighttime sky, so maybe we can do another moon solar system webcast where we do the moon and the planets, and the comet. So, but we are getting into monsoon season, so weather's getting choppy. So, just keep an eye out on our social media pages. We're going to start offering these once a month, so we're getting away from the every other week and moving to once a month. Keep an eye out on our schedule, and you can check out what is coming up next. But thank you all for joining me. I hope you have a safe weekend. Stay healthy out there. I know it's kind of a weird place right now, but we'll get through it. And until then, get yourself a telescope. Go out and explore. You may not be able to leave your house, but there's billions of things to explore above your head without ever going anywhere. So my name is Kevin Lagore with Focus Astronomy. Thank you very much, and we will see you under the stars very soon. Take care, guys.